Hello everyone, welcome to this session. In last lecture, we have seen the various aspects which are associated with the groundwater hydrology, and moreover we have also seen the various terminologies which are related to the flow conditions in a ground, right? So the important 2 points are the theories which are expressed by the two various scientists which are Darcy and Dupin. So that also we have seen. Actually, in this session, I'm giving the more stress on how to determine the permeability actually, which is uh, we are studying in the access to the syllabus, but regarding the knowing the how the flow conditions are there and how the Darcy's law is worked out uh, by the various say, laboratory tests. So that also we have seen. So in today's session, so we are going to see how the Darcy's law validates and how the uh, coefficient of permeability it is worked out in the laboratory and how the Darcy's law can be proved, right? So permeability that you know that because of that the flow in the groundwater that occurs or the flow takes place, and Darcy's law is associated with that. So we have seen also the equation regarding the Darcy's law. So we are going to see the two different tests. One is a constant head and the varying head test to determine the coefficient of the permeability. So also the related aspects, how the Darcy law is validated. So that also we are going to study. So permeability, as we have you see that why we are going to study in detail, because this is the parameter which is allowing or the permitting the water to flow in the ground, right? So permeability is defined as the property of the soil which permits the flow of water through it. Soil is highly pervious when water can flow through it easily. For example, gravels and in an impervious soil, the permeability is very low and water cannot easily flow through it. For example, clays are there. Of course, the rocks are impermeable, and permeability is very important engineering property of the soil. That's why, especially in spite of not, it is not being included in the syllabus regarding the permeability test. So probably it may be asked if any examination in the gate examination as well. So that you must know, right? So that we are doing today we are going to study in excess. So knowledge of permeability is essential for the settlement of the building, yield of wells. Okay, so how the water can be extracted, seepage through and below the earth's structures, earth pressure, uplift pressure under the hydraulic structure, right? So all these especially parameters which require the knowledge of permeability. Now, what are the various factors which affect the permeability of the soil? Now, there are so many factors which are affect. First one is the particle size. Of course, all these points are you can say self-explanatory. Okay, so particle size, if it is smaller, definitely the permeability will be low, and vice versa. If the particles grains are of more size, the void will be more and permeability will be more. Then similarly, you can have the same kind of self-explanatory uh, discussion on this. For example, properties of the pore fluid. Okay, what kind of fluid is flowing through the soil? Void ratio of the soil, right? Shape of the particles. That depends again whether the round particles are there, conical particles are there. Structure of the soil mass. Okay, what kind of structure is there? Compacted, well compacted, semi compacted, likewise. Degree of saturation. Okay, whether the saturated, semi saturated, or fully saturated. Absorbed water, how much water has been absorbed, and various impurities which are also contributing this permeability. Now, especially we are discussing regarding the how to determine this permeability in the laboratory. Just we are giving some special stress on this because this will be important from the examination point of view as well as the examination like the gate examination is there or the MPSC, UPSC. So I found that most of times the examples are asked on such particular points. So that's why we are discussing today. Right. So if you see the various methods to determine the coefficient of permeability. So if you know the equation of the Darcy's law that Q is equal to K into I into A. Right. So where that I stands for the hydraulic gradient is the cross-sectional area. Okay, I that you can understand that how it is worked out that based upon the head loss which is present there, right? Head loss and the length of that particular mass HL by L, right? And K is the coefficient of the permeability which is worked out. Now there are three types of you can say the methods are available to determine this coefficient of permeability. One is the laboratory method, field method, and indirect method. In the laboratory method, so constant head permeability method and falling head or uh, permeability method. In the field methods, we have seen that also how the pumping test is carried out, pumping out test and pumping in test. Both the tests are there. Okay, and indirect method by computation from the particle size and computation from the consolidation test. So these are the tests which can be indirect methods to work out this, right? Now to find out the this coefficient of permeability, as we have discussed, there are two types of tests are there. First one is the constant head permeability test. And what is object to determine the coefficient of permeability of a soil specimen by a constant head method. Now various equipments are there. Permeability mold is there. Internal diameter of 100 mm mold is there. Height of that effective height is 127.3 mm, which is standard one. Capacity it is 1000 ml, complete with the all other accessories. So there are other accessories are there to fit the knobs, etc. Then constant head tank. So on the upper side, uh, one tank is provided. From that water is continuously supplied to this particular mold. So which is passed through that by with a continuous or you can say uniform water supply. Graduated cylinder, stop water, thermometer, filter paper, vacuum pump, weighing balance, okay, of a good accuracy. Then you can see this test, the upper overhead tank is there. So this is the supply pipe or standpipe is there. This is the sample through which the water we are going to pass it, and it is a measuring cylinder. Okay. So these are the equation that we have already seen, and this coefficient of permeability is worked on the this discharge, time measurement, length of the sample, hydraulic gradient, and the cross-sectional dimension, or you can say area. Okay, so this is the way. So here important is that regarding the data collected here in the measurement measuring cylinder, and also the time for that, right, and this head, so to find out the hydraulic gradient. So all this data is necessary. The same thing is with the falling head also there. So only the head which is changing there at in that second test, right? So this is the setup which is used. So I will read just only the test procedure. Measure the internal dimension of the mold. Apply a little grease on the inside the mold. Take about 2.5 kg of the soil from a thoroughly mixed wet soil in a mold. Compact the soil at the required dry density using suitable compacting device. Remove the collar and the base plate. Trim the excess soil level with the top of the mold. So the mold that should be filled properly. That's the meaning of that. Clean the outside of the mold. Find the mass of the soil in the mold. Take the small specimen of the soil in container for the water constant determination. saturate the porous stones, place the porous stone disc on the drainage base and keep a filter paper on the porous stone. Place the mold with the soil on a drainage base. Place a filter paper and a porous stone on the top of the specimen. Connect the constant head tank to the drainage cap inlet. Open the stop cock and allow the water downwards so that the air is removed. Then close the stop cock. Now again open the stop cock and same time start stopwatch as well. Collect the water flowing out of the base and measuring flask for the some convenience interval. Measure the difference of the head edge in levels between the constant head tank and the outlet in the base. So if you see here, so how the filter paper is provided here, this is the porous stone here also a porous stone is there, here also filter paper is provided. So this is the soil sample which is present. Okay, so what is the necessary of providing these particular porous stones? To avoid the damage to this soil sample, and that water which is supplied to the sample, that should be uniformly spread over the soil sample, and our results we will get it accurately, right? So all these measurements which are associated with the accessories: cross sectional area of the specimen which is worked out, volume of the mold which is worked out with the regular formulation, mass of the wet soil in the mold, that is mass with the empty mold and mass with the wet soil. These both are worked out, and these two densities are also worked out, and finally the results, or you can say coefficient, is worked out by using the same formulation. Okay, so the very simple experimentation is there to find out the permeability. Then let's discuss regarding the falling head permeability. What is to determine the coefficient of permeability of the soil specimen by a falling head method, right? All the equipment which are required in constant head permeability test, only here what we are seeing is, we are providing the falling head here. So instead of overhead tank, we are providing the funnel here, stand pipe, right? And you can see the find out the differences. We have to understand the various heads there. All other things are same, right? So here the formulation that regarding the instead of the constant head, now we are finding out the, especially with this formulation, the k is equal to 2.3. okay, so q into l divided by a into t into log 10 raised to h1 by h2. So this formula is used to find out this. So what is the different thing here, that prepare the remodeled soil specimen in the permeameter and saturate it. Keep the permeameter mold in the bottom tank and fill the bottom tank with the water up to its outlet. Connect the water inlet nozzle and mold. Standpipe is filled with the water. Permit the water flow for some time till the steady state of the flow is reached. Now open the valve of the standpipe and record the time to fall the head from H1 to H2. So here, instead of keeping the constant flow through the pipe, what is done, that from a certain level of water, okay, to the next level of water, it is the time is observed. That is the difference between the two tests. Repeat this test at least twice. Okay, so some more observation can also take. So what is constant head permeability test is used for the more permeable soil like sand. Okay, where the porosity is more, you can say. Falling head permeability test is used for the less permeable soils like clay also. Okay, so this is the formulation which is used for the finding out by using the falling head permeability. Okay, so you must know this test, that's why I have repeated here. So actually not necessary to go through that, but actually we have to prove the Darcy's law, especially for the confined and unconfined aquifers. So that also we have seen earlier, and we will again see in detail in the coming sessions. Now let's have the glance on the Darcy's law and its validity. We have seen Darcy's law. Now before that, Also, let us discuss regarding the Darcy, the scientist who has contributed so much um, for this flow through the soil. As many scientists are there. Remember, for example, if you see the soil mechanics, Terzaghi is there, who has carried out so many experimentation, and he's supposed to be the uh, most important contributor in the soil mechanics. Similar thing is there if the flow through the soil is there. Darcy is the name which comes first, right? And so many other also scientists are there, which those who have also contributed. Now, regarding the Darcy, Henry Filbert Gaspard Darcy was born on June 10, 1803 in Dijon, France. What is his contribution? That most important contributions to flow and friction loss in the pipes created improved pitot tube design, and was first to postulate the existence of boundary layer in the fluid flow. In 1856, he carried out experiments while researching sand filters that led to the Darcy's law. Okay, in 1856 it was the Darcy's law came into existence. Okay, and he passed away in 1858, right? So his contributions are more to this field. Now, what Darcy's law that we have seen, it was first studied in the 1856 for a laminar flow through the saturated soil mass. The discharge per unit time is proportional to the hydraulic gradient. So this equation also we have seen, and what are the various aspects which are associated with that also we have seen. But I will repeat once again that Q is equal to K into I into A. So where again, so this Q divided by A, that comes to be as a V, right? And again we can also alternately we can say that V is equal to K into I, which also we can say as a Darcy's law, where Q is the discharge per unit time, which is also called as the rate of flow. A is the total cross-sectional area of the soil mass. I is the hydraulic gradient, which is H divided by L. K is the Darcy's coefficient of permeability. V is the velocity of the flow or discharge velocity, right? So this explanation also we have also discussed regarding this. If the this is the one head and another head is observed here, so this is the length of the soil mass, right? So how the flow through a water occurs? So this head loss H1 minus H2. So if a soil sample of length L and cross-sectional area A is subjected to differential head of water H1 minus H2, the hydraulic gradient I can be worked out as a this difference H1 minus H2 divided by L, right? So Q is equal to K into H1 minus H2 into numerator divided by L into A. So V is equal to K into I, that we know. So hydraulic gradient I, that can equally to the unity V is equal to K in that case. So especially now here after all my sessions, all my lectures will be associated with the also GATE examination syllabus. Little bit we are going to study apart from the our regular syllabus as well, as demanded by my students as well. So those students who are appearing for the GATE examination, please go through all this theory very properly, and in the regular also the our syllabus also please go through this theory that may be asked in the examination. So what are the assumptions of Darcy's law that we have also seen, but I will repeat once again. The soil is saturated, the flow through the soil is laminar, the flow is continuous and steady, the total cross-sectional area of the soil mass is considered, and the temperature of testing is at 27 degrees Celsius, which is a normal one. Then validity of a Darcy's law, right? So Darcy's law is valid if the flow through soil is laminar. The flow of water through soil depends on the dimensions of the particle. In fine grade soils, the dimensions of the interstices, or the it is called as the voids, are very small and flow is necessarily laminar. In coarse grained soil, the flow is also laminar. However, In very coarse grained soils such as gravels, the flow may be turbulent. For flow through soils, the flow is laminar if the Reynolds number is less than unity. As per the Hazen, you can say the maximum diameter of the particle for the flow to be laminar is about 0.5 mm. So that is worked out. It is valid for the flow in the clays, silts, and fine sands, coarse sands, gravels, boulders. The flow may be turbulent and the Darcy's law may not be applicable. For Darcy's law to be valid, the relationship between the velocity and the hydraulic gradient I should be linear, and extremely fine grained soils such as colloidal clay, then interstices are very small, the velocity is therefore very small, and in such soils the Darcy's law is not valid. Okay, so this validation is necessary to understand this Darcy's law, under what condition it is used. So please remember all these things from the examination point of view, as well as their hereafter from the professional examinations, or you can say competitive examination point of view as well, right? So friends, today we have discussed regarding the Darcy's law and it associated various tests and validity of that. So hereafter the students are also requested to go through the various question papers, which are also try to see the various numerical example which are asked, try to solve those examples, keep separate notebooks for the all the subjects, especially the subjects I am teaching, that water resources and the water supply engineering. So keep the separate notebooks, try to find out the question papers from the Shivaji University, right? Solve the examples, take the help of the notes which are supplied, use the various sources, do not waste your time, and work as a professional point of view, as well as a study it from the competitive examination point of view. So here in every lecture I will try to also give some hint regarding the these competitive examinations, right? So we'll stop here today. Thank you very much for joining today's session.